Hello, my name is AshutoshGodara and I'm going to present spatial technology hands-on assignment demo, and my topic is Spatial Hadoop, and following is my student ID and email ID. Yeah, so agenda for this demo is first I'm going through with what is a spatial Hadoop, and after that I try to retrieve counting in specific range using range query operation on big spatial data set of counties in USA on spatial Hadoop. So I'm going to calculate this range query on three different indexes: grid, R plus tree, and quant tree. And finally, I compare the execution time taken by spatial Hadoop on these three different type of index file for range query. Yeah, so what is a spatial Hadoop? Spatial Hadoop is a map reduce framework for spatial data. It is an extension to Hadoop with spatial data inside the core functionality of Hadoop. So Hadoop was developed to support or to analyze big data, and spatial Hadoop is to analyze spatial big data. Now, it gives several features. So first is spatial language, that is pigeon by which user can communicate through system. It also provides spatial data types. The built-in data types are point, rectangle, and polygon. A user can also define their own data type based on their input file. And spatial indexes support is grade, R plus tree, quad, zcar, all the spatial index spatial Hadoop supports. And apart from that, the main thing is spatial operation. All the majority of spatial operation spatial Hadoop supports. So I'll go with the I'll show this operation in my demo. Now what I did to calculate a range query. So first of all, I downloaded a data set from officially a spatial Hadoop site. And for that, the data type they used is Tiger, that is already built in spatial Hadoop. And the next is I need to upload that CSV file, that input file, into Hadoop distributed file system. And after that, I need to generate an index file. So for index file, first I need to make a MBR. I need a data for MBR. MBR is nothing but minimum bounding rectangle. So these are the commands to calculate that. And after that, I'm going to create an index file. So based on the different types of index, these index files are going to create it with shape equals to Tiger. And Tiger is a user-defined data type, spatial data type. It is internally converted into either point, rectangle, or polygon based on the configuration of input file. And after that, spatial Hadoop also provide a cool feature to visualize index files. So I'm going to present that as well with a spatial operation plot to plot the index file in front end. And once index file is calculated or created, then I'm going to execute spatial range query operation on index file to calculate a specific range of quantity in a given range. Once given range, and the output of that file, output of that range query will going to stored in a file. We can, a spatial Hadoop can also provide a spatial operation called read file, or that it can read the file on in output itself, std output, or to get a better visualization, again we need to create an index file of output range query file, and we can also see that in front end. I'll show that in my demo. So next is I'm going to execute all these tasks for first grid indexing, and then I'm going to calculate the range query with R plus tree indexing file, and finally with quad tree indexing. Yeah, so let's switch to the demo. So this is the virtual machine I have created. So this already installed Hadoop. And let me check the file system for this. And let me check the spatial Hadoop is available or not. Yeah, it's configured, is available, and it's a help for spatial Hadoop. These all are the spatial operations. Like for example, index, if you wanted to create index files, range query, KNN, all the general spatial operation it provides. Now, first of all, I'm going to download a file from spatial site. So this is the official spatial Hadoop site and dataset. And when I click on dataset, it will show these many a big spatial data set. So I downloaded for quantity, and I downloaded this file in my system. And once I downloaded, then I need to copy that file into Hadoop distributed file system. So for that, first of all, I need to execute this command. So Hadoop file system, copy from local. There is a location. I already copied that, so it's already present over there. Now, I need to create a index. So first, I am going to create an index file for grid and then calculate the range query on grid index. So to generate a index file on grid, first I need a MBR, minimum bounding rectangle, for that. And so over here, this is the rectangle output. I need to use this in my command. So over here, we can see, so this is the command to generate a index file with grid index. So spatial Hadoop and then index, this is input file, and this is the output file, which is in the grid index. This is S index, is nothing but spatial index, and shape is from input file, which is tiger, and then MBR, which we already calculated in above command. Now it's going to create a index file with grid. Yeah, it's created. Now I'm going to see. Now I'm going to execute a range query. So range query is nothing but this is our input file, and this will be this input is index file, output would be this new file, and this is our range query. So in this range query, we are going to calculate the counties from USA. So it gives us 2483 as the output. And now either we can see this output over here itself with spatial Hadoop refile operation. So it will give us all the 2483 like tiger, and it could be polygon, rectangle, or anything. So this is the data. So to visualize this data, first we go to the spatial Hadoop's UI part. So it's give a feature by which we can plot our index file in UI to see what are the files and what would be our results. So over here, if I can see, so county.grid is an index file for a grid, and this is the county.grid file. If we wanted to plot this file to see what is the output of our how does our index file looks like. So it's going to take some time. Yeah, so this is how our overall input file. So these are all the counties in United States. Now to see our result file, we also need to create an index of our resulted range query file. So I'm going to create an index file of that. So this is how it's going to be created. So spatial Hadoop index, and this is our input file, which is the file which we calculated from range query. So the index file is generated. Now let's see what is the output in our range query. Yeah, this is how our range query result looks like. These are nothing but 2483 counties, and which is in grid indexing. I'm going to calculate the index file for R plus tree. So this is the command to generate index file for R plus tree. So over here we need to just give strr plus. This is the name for R plus tree spatial index. And once the index file is created, I'm going to run the range query. All these laws are nothing but that map reduce algorithm is running on backward. Now I calculate a range query on R plus tree indexing. It should give the same output as 2483, which we already got from grid indexing. So 2483. Now we already have a range query result from R plus tree. Now I'm going to create an index to visualize this output on front end. So this map reduce framework is executing some of internal defined function for spatial operations. That much of time. Now let's see what's the output and how does look like the indexing for R plus tree. So if I can see this county.sci, this is our input file indexing. Yeah, so this is how the R plus indexing looks like. So two files with these two tree childs, and this is input file indexing. And now we are going to check with R plus tree indexing. So this is how our range query results looks like in R plus tree indexing. Yeah, so yeah, after that I'm going to calculate the range query for quad tree. So due to timing constraint, I already calculated for quad tree with just changing the spatial index to quad tree, and these are the files for quad tree. So this is how the quad tree indexing looks like, and what is the range query output for quad tree. So this is our range query output for quad tree indexing. So all the output is 2483 counties in that specific range. Yeah, so that is all with respect to demo. And finally, I have calculated a performance evaluation of range query execution on spatial Hadoop for grid index, R plus index, and quad tree indexing. And for my input file, a grid index is really better with respect to performance, and R plus tree and quad tree are taking some more time. It's totally depends on input file. I just took a very small file, and if the file size is bigger and bigger, and then these indexing or performance might change. Yeah, so that's all from my side. Thank you.